these are the old cables. Nowadays, all these are cables are replaced by these type of small cables. So this is nothing but external bus system, and these are another ordinary cable. Once if you switch off the computer or when the system is shut down, those data stored in the RAM will not be available for next time, whether there is a power or there is a power failure. So it works continuously as if you are getting the continuous power supply from the main power. Dear students, I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today we will continue our discussion with remaining parts of the motherboard or remaining components of the motherboard. Let us start with bus system. It is one of the component of the motherboard. Here, what is a bus system or what is a bus? Actually, and what we have learned so far is there are so many components on the motherboard, so many hardware devices are connected to it. And how do they communicate, or how all the components on the motherboard communicate among themselves? How data is going to transfer? How control signal is going to transfer from one hardware to another hardware, or one device to another device? See, all these things are possible through a bus system. Now let us see what is the definition of bus system. So a bus or a bus system is a collection of parallel wires that form a pathway to carry address, data and control signals. So this is the bus system where it's going to carry the data, because for processing and control signal from control unit and also memory address. So all these has to be transferred or shared by different hardware devices on the motherboard. So that is possible through bus system. Normally, we don't use the word here cables. This is a sort of cables, but here we use the word bus system. Now you can see the diagram here. So this is the bus system. This is CPU and memory and input and output devices. The meaning of this diagram, and you can observe the arrow marks shown in the figure here. So this is how the data or address or control signal transfer from CPU to memory and memory to IO devices, Intel. So this is possible because of the communication is possible, or communication takes place on different devices among different hardware on the motherboard through bus system. Now let us see again one more point on the bus system. Buses are the pair of wires or a circuitry which is used to transfer the data, as I told you just now. So it is a combination of, or it is a pair of wires. Here we use the word cables or wires, and it is through which the data is transferred. So more is the capacity of the bus, faster will be the execution of process or request. And the speed of the bus, rate at which the data is transferred, is measured in terms of megahertz. So the communication is going to be very fast. It depends on the capacity of the bus system. We can see there are two types of bus system. One is internal and second one is external bus system. So what is the difference between these two? If you look at the difference here, this internal bus or bus system, it connects major components like processor, memory and IO devices. It is also called as system bus, and it comprises of three kinds of buses like data bus, address bus and control bus. So what is the internal bus? Hey, if you look at the microprocessor, it is all the three parts of computer, like the major component like memory unit and control unit and ALU will be fabricated inside a microprocessor. So inside the microprocessor, how do the different components are communicate? That is nothing but that is through internal bus system. So that is why the communication between the processor and the memory and IO devices. So all these takes place through this internal bus system. And again, internal bus system is categorized into three more bus systems, that is data bus, address bus and control bus. Now look at what is external bus system. External bus system, it connects external devices like peripherals, expansion slots and I/O ports. See, apart from, there are so many parts on the motherboard, so many hardware on the motherboard. So apart from, rest of these things will be connected through external bus system. So generally, a bus system is used to communicate between different hardware devices. Next, we move on to next slide, and here you can see the pictures of internal bus, external bus and ordinary cable. This is bus system, and here we don't generally use the word wires or cables, we use the word bus. Internal bus, it is the one, you can see the diagram here. This is to communicate within the microprocessor. So between the memory, ALU, control unit, everything. These are external bus cables or external bus system which are connected to different hardware devices on the motherboard. And here you can see the width of the cables. These are the old cables. Nowadays, all these are cables are replaced by these type of small cables. So this is nothing but external bus system, and this is another ordinary cable. This is the pictures showing the different types of cables under system bus. So there are various buses that are present in the system. Some of the important are front side bus, back side bus, control bus, address bus, AGP bus, PCI Express bus and PATA or SATA or SCSI. This is called SCSI cable or bus system. See, and you can see the diagram here. You can see the picture. These are all different types of bus system. And these are the one, as I told you just now, this one, and look at this one, or old model. Nowadays, all these are replaced with new type of bus system or cables. So this is the types of bus system. Now let us see the definition of different type of bus systems. One is data bus. Data bus provides path to transfer data between CPU and the memory. It consists of 32, 64 and 128 lines of wires, as it is a combination of parallel wires. So it is the communication between CPU and the memory. That is through data bus. Next one is address bus. It connects CPU and RAM, and it determines the maximum number of memory locations the computer can address. And PCs presently have a bus speed between 100 to 400 megahertz. Now let us move on to another component, that is computer memory. Now all of us know that what is the use of computer memory. So computer memory is used to store the data and instructions in the computer. This computer memory, it refers to the electronic storing space for instructions and data. And all of us know that the computer memory is a limited memory. So computer memory processor has a limited memory. So it can be of two types. One is internal memory as well as secondary memory. Internal memory, again, it includes registers, cache memory and primary memory. So what is the computer memory? It is one of the components on the motherboard. Then we are used to store the data and instructions. And again here, there are two types of memory, internal as well as secondary memory. One of the internal memory is registers. What are registers? You can see the diagram here. These are all nothing but, again, ICs or integrated circuit chips. So here, registers. These registers are high-speed temporary storage areas located inside the CPU, nothing but inside the microprocessor. The data and instructions are moved to registers for processing. These registers work under the direction of the control unit to accept, store and transfer instructions or data and perform arithmetic and logical comparisons at the high speed. So this is the function of registers. So generally, register is a memory located inside the microprocessor used to store small instructions, and it works under the direction of control unit, and responsible and functions is to accept the data, store the data and transfer of instruction for data processing. The cache memory is a high-speed memory available inside the CPU to speed up the access of data and instructions stored in RAM memory. So look at the diagram here. This is the cache memory and there are three levels of cache. Level 1, level 2 and level 3. Level 1 is inside the CPU registers and level 2 is between the memory and the CPU. So here generally what is a cache memory? It is a high speed memory used in the system. Now let us move on to next slide. Here this cache memory is built into the processor as you can see in the diagram here, L1, L2, L3 here. So L1 and L2, L3 cache stores most recently executable instructions, the next ones and the possible ones respectively. So these are the three levels of cache memory, stores different instructions or information. One is most recently executable instructions, next ones and the possible ones respectively. And L2 is located outside the processor. This is what we call CPU is the processor, L2 is outside the processor and L3 is located between the RAM and the L1 and L2. So this is about the cache memory, that is another type of fast memory. Next slide is another type of internal memory, that is a primary memory or internal memory. This primary memory, it is the main memory and it is of two types as we have learned last year, RAM and RAM. RAM stands for random access memory and read-only memory. What is the difference between these two here? We can see the difference here. RAM, it is faster as compared to ROM here, and RAM is a temporary memory and it is a volatile memory. What is the meaning of volatile memory? I mean the information or data stored in RAM or it is stored only temporarily. The meaning is that once if you switch off the computer or when the system is shut down, those data stored in the RAM will not be available for next time. That is the meaning of volatile memory. And what is ROM? If you look at ROM, is the permanent memory and non-volatile. Non-volatile means it cannot be erased. So once the data is stored here, it will be there permanently. We cannot be erased or it cannot be modified. That is the difference between RAM. This is main memory, primary memory or internal memory. Again, this primary memory, we can see there is different types of RAM here. One is, you can see the diagram here. This is for the memory, RAM here, and types of RAM here. Here DRAM, it is 8 DRAM. It uses the transistors and capacitors. It must be refreshed continuously and it is slow. And this is D stands for dynamic RAM. Dynamic RAM, it consists of transistor and capacitors. Now look at SRAM. S stands for static. Static random access memory. It consists of multiple transistors and here no capacitors, and it need not to be refreshed every time. And that is the difference between these two, and it is faster as compared to dynamic RAM or dynamic random access memory. And again it is SDRAM, that is synchronous dynamic random access memory. So it synchronizes to the system clock and it increases the efficiency by reducing CPU waiting time. That is the advantage of this SDRAM as compared to SRAM. Now look at the DDR-RAM. So this is synchronizes to the system clock. It increases the efficiency by reducing the CPU waiting time. Now here, what is DDR? It is double data rate. Actually, DDR SDRAM stands for double data rate synchronous dynamic random access memory. So the capacity of DDR SDRAM is double to SDRAM. So this is a type of RAM or different types of RAM. This is the RAM slot. Next one, you can see the another type of primary memory is ROM, read-only memory. You can see the diagram here. So read-only memory, it is a non-volatile memory, just we have seen in the previous slide. It is read-only memory, is the permanent memory. And here, what are different types of ROM here? PROM, programmable read-only memory, and EPROM, erasable programmable read-only memory, and EEPROM, electrically erasable programmable read-only memory. Actually, RAM, what we say, it is a permanent memory. I can give an example like any home appliances like washing machine. Most of you have used washing machine at your home. So all this, if you want to use washing machine, you will be programmed for water level as well as different types of washing here. So all these what you're using here, it is based on this RAM chip, and that is the RAM chip. It will be placed in the as a circuit board. So those we are operating it. So that is a permanent one. Now let us see the different types of ROM, that is PROM, EPROM, EEPROM. These are the types of ROM chip what normally we use in home appliances like washing machine or oven, etc. We are using those home appliances according to our requirement by setting the different parameters. So all these are example for this ROM, that is read-only memory. It cannot be changed, it cannot be programmed. But we have different types. Again, it is PROM, programmable read-only memory. All these chip available in, as I told you just now, in home appliances what you're using now, all these are programmed chip or programmed ROM. Now next one is EPROM, and the same ROM chip, it can be erasable and programmable, and if any problem with any of the chip here or the ROM chip, that can be erased and that can be programmable. So that is nothing but EPROM. And EEPROM, electrically erasable. I mean, as in the previous example we have seen that ROM program can be erased. How it is possible? By using different technique. One of the technique is by using electrically erasable or by using electrical power to erase the program in the ROM chip. So this is about ROM, that is read-only memory. Next we move on to one more component on the motherboard, that is power supply or power system. And here, as all of us know that, see, whenever we want to work with the computer system, it has to be powered with the power cable. So here there are two types of power supply to our computer system. One is SMPS and one is UPS. Now let us discuss this one by one. First one is SMPS. Full form is switched mode power supply. The full form of SMPS is this. See, this is the diagram of SMPS, and this will be inside your CPU cabinet. And here, what is the function of SMPS? Here, function of SMPS is it is going to regulate the power supply from our main AC. So generally, if you look at, we know that in the power supply, if you use any power plug from the main socket, it gives us around 230 to 250 volts of power supply. It has to be regulated or it has to be converted to the required amount of power to the hardware devices on the motherboard. For that, we need to use the SMPS. It is used to regulate the main power supply from the main electricity board. That is the purpose of this. Now, let us move on to next slide. This is UPS. This is UPS, and full form is uninterrupted power supply. Uninterrupted power supply, that is what UPS. Now you might have come across these type of devices here. This is one tubular battery and this is small UPS. Actually, what is UPS? Uninterrupted power supply. Here the meaning is that whenever the computer system, it requires a continuous power supply to work with. So here UPS, it provides a continuous power supply in the absence of main power. That is the definition of UPS. That is why we are using UPS power system. Now look at the types of UPS. Here one is online UPS and second one is offline UPS. And here this online UPS, and here it provides continuous power supply from own inverter even when the power line is functioning properly. And here there are two types of UPS system. One is online, one is offline. In online, normally all these UPS systems, you will be using a battery inside it. So that is the battery to store the power. So in online system, the UPS is connected to the system. If it is online, the computer or the system will get the power supply from the battery or inverter inside the UPS, even though there is a power, or even in the presence of electricity or the main power, still the computer or the system gets the power from the inverter present inside the UPS, that is online UPS. And here normally the user will not be knowing that whether there is a power or there is a power failure. So it works continuously as if we are getting the continuous power supply from the main power. That is about online UPS. And what is offline UPS? In offline UPS, it is when power line is switched over to battery power as well as a power failure. Here the difference is that as soon as there is a power failure, immediately the UPS switch over to battery mode. So as long as there is a power, it will be in the power line mode. So once there is a power failure, if the power cut down, immediately the UPS switch over to battery power mode. So then immediately we are start getting the power supply from the battery of the UPS. So that is the difference between these two. And here in online UPS, even though there is a power, we will get the continuous power supply from the battery or inverter inside the UPS. And here in offline UPS, when there is a power, we will get the current or the power from the mains. And if there is a power failure, immediately we'll get it starts providing power from its battery. That's the difference between these two. So if you look at the online UPS, normally we are using this online UPS in our critical conditions where we require to have a continuous power supply without any power failure. So these are about the UPS and types of UPS. Thank you very much.